Divisible model. The next one is divisible model. The first example is 49 power n plus 16n minus 1 is divisible by 64. Show that 49 power n plus 16n minus 1 is divisible by 64 for all n belongs to n by using mathematical induction. By using mathematical induction. Let us consider the statement is considered as S of n is equal to 49 power n plus 16n minus 1. The statement is considered as 49 power n plus 16n minus 1 for n equal to 1. That implies S of 1 is equal to 49 plus 16 minus 1, that is equal to 64. That is equal to 64. 64 is divisible by 64. Therefore, S of n is divisible by 64. Therefore, S of 1 is true. S of 1 is true. Let us assume that S of k is true for k belongs to n. The statement is true for n is equal to k. That is, S of k is equal to 49 power k plus 16k minus 1 is equal to some multiple of 64, that is 64m. Here 49 power k is equal to 64m minus 16k plus 1. That is considered as equation number 1. Let us assume that the statement is true for n is equal to k for all k belongs to n. That is S of k is equal to 49 power k plus 16k minus 1, that is equal to 64m. That is a multiple of 64. Therefore, 49 power k is equal to 64m minus 16k plus 1. Now we have to prove that. S of k plus 1 is true. S of k plus 1 is true. That is, S of k plus 1 is equal to 49 power k plus 1 plus 16 of k plus 1 minus 1 is equal to 49 power k into 49 plus 16k plus 16 minus 1. Then plus S of k plus 1 is equal to 49 power k into 49 plus 16k plus 15. That is equal to 49 of 64m minus 16k plus 1 minus 16k plus 1 plus 16k plus 15. Since from condition number 1. From condition number 1, 49 power k value is 64m minus 16k plus 1. Multiply 49. Is a 49 of 64m minus a 49 of 16k plus 49 plus 16k plus 15. Here 49 plus 15 is 64, and second term and fourth term minus 16k is common. Is the 49 of 64m minus 16k is common. As the 49 minus 1 plus 64. 49 minus 1 plus 64. That is 49 of 64m minus 16k of 48. 48 can be written as 12 fours are plus 64. 64 is common. 64 of 49m minus 16 of 4 is equal to 64. That is a 12k of 64 plus 64. In total 64 is common. That is 64 of 49m minus a 12k plus 1 minus 12k plus 1, that is the multiple of 64 is always divisible by 64. Therefore, S of k plus 1 is always divisible by 64. Is always divisible by 64. That implies S of k plus 1 is true. S of k plus 1 is true for all k belongs to n. Hence, by the principle of mathematical induction, S of n is true for all n belongs to n. For all n belongs to n.